Hello, geometry students. So far in Chapter 10, we have been studying circles and we have learned central angles, we have learned inscribed angles, and we have talked about tangent lines. In Section 10-6, we're going to talk about secant lines, tangent lines, and the angle measures that they create. And so we know already that a tangent line is a line that intersects the circle only at one point, and so that would be a tangent line. Let's look at what secant means. A secant line is a line that intersects a circle at exactly 2 points. So take a minute and draw a secant line. So I need a line that intersects the circle at 2 points. So that would be a secant line. Let's take a look at the angles that are created by secant lines and tangent lines. In our first example here, we have 2 secant lines or 2 chords that are intersecting in the interior of the circle. So here are my 2 secant lines. They're intersecting in the interior of the circle. And so here I have angle 1. Now that's not a central angle, that's just an inside angle. And so to calculate that angle, angle 1, you have actually 2 arc angles that are created by that angle. See angle 1 here? PR is created by angle 1, and then I have vertical angles. So SQ is also created by angle 1. So to find angle 1, you're going to add the 2 arc angles that are created by it, which is PR and SQ, and then they say multiply by a half, or you could divide by 2. Now, I'm not always going to have this picture here, so I have my own little formula here. If I have an inside angle, I'm going to take the arc, angle 1, which would be this one, plus the arc 2, and then divide by 2, and arc 2 would be right here. So I don't have to have that picture. When I have inside angles, I'm going to add them, and then I'm going to divide by 2. I'm going to add those 2 arc angles and then divide by 2. In our second example here, we have a secant and also a tangent line. So do you guys see here? This is my tangent line. Here's my secant line. Now, this is on the edge of the circle, similar to an inscribed angle. And remember when you had inscribed angle? If this was 20, you would write 40 there. Same thing applies here with the secant line. Secant line and the tangent line. You know, and this is vice versa. Half of the arc angle is going to get you your angle. And so that's what they have, is they have this arc angle here that it's created. Right there, I'm going to take half of it to get the angle. So it's very similar to an inscribed angle. Inscribed angle is always half of the arc angle. Let's take a look at our last couple of examples down on the bottom. These are all outside angles. Outside angles, the angle outside, the angles outside, and the angles outside. They all have the same formula. When I had an inside angle, I added the 2 angle arcs, and then I divide by 2. When you have an outside angle, the rule will be, it's right here for this one, the rule would be take the big arc, which is BE, that's the arc angle that is created by your angle, BE, and then subtract it, the smaller one from it, which is AD, and then multiply times half or divide by 2. So once again, I'm not always going to have my picture, so I'm not going to memorize this formula, but I'm going to write my own generic formula. When I have an outside angle, I'm going to take my big arc, that's the arc that is created by the outside angle as it intersects the circle. I'm going to subtract my small arc, and then I'm going to divide by 2. So let's take a look here for just a minute. I'm going to draw a picture. All right, there's my outside angle. Here's my outside angle. This would be the big arc that's created. And then right here, see how this angle is cutting through the circle? This would be my small arc. If you're wondering what I'm talking about there. Okay, so now that we have our formulas, let's go ahead and take a look at our examples. All right, it says find each measure, assume that segments appear to be tangent are tangent. So in example number 1, I'm looking for angle 1. Okay, that's an outside angle. Outside angle, that was the big arc minus the small arc. And then I'm going to divide by 2. That was the rule that I had written on the other slide. So when I look here, here's angle 1 cutting through the circle. This is my big arc, 80 minus, this would be my small arc, which is 40. So the measure of angle 1 equals 80 minus 40, and then I'm going to divide by 2. Right? So now my measure of angle 1 equals 40 divided by 2 is 20, and I should write degrees there, people. And that's my final answer. So I'm going to box it in. Let's look at example number 2. This time I'm looking for the measure of arc angle N, LN. So I'm looking for this arc angle. So once again, I have an outside angle. So I'm going to use, oops, my apologies. I'm going to use this formula right here. So I know my outside angle, it's 50. So I'm going to write 50 equals. I need to take my big arc. Okay, there's nothing there, right? And then, so then you're thinking, well, I'm going to look for my small arc. And there's nothing there either. So you got a little bit of a problem here, and you don't want to write 2 variables. Notice here that this is a tangent line, and that is a tangent line. So let's say that was tangent, and that's tangent. If this is 100 over here, how much would this side be? Right, that's 100, so you would take 360 minus 100, and you would write 260 on this side. We're going to have to do the same thing here, people. I don't know this arc angle, so I'm going to call that X. And this small arc is going to be 360. Oops, wait a minute here. I'm going to change that. I'm looking for the measure of LN. Mrs. Hefty. Let's erase this. I made an error here. That's only 2 letters, so that would be my minor arc. I'm really looking for this side here, is what I'm looking for. So I'm going to call that X. There's only 2 letters, so I'm looking for the minor one. This would be the major one on the other side. That's the bigger arc. So I'm looking for the smaller one. So this side here is going to be 360 minus X, just like I did over on the problem up above. This was 100. So then I wrote 260 on this side. All right, so now I have my angle. My outside angle is 50 equals. Now the next thing I need to do is I need to take my big arc minus my small arc. This is my big arc here. That's 360 minus X. And then I need my smaller arc. There's my smaller arc, so I'm going to minus X. So do you people see here that I've written 360 minus X, which represents the big arc, and then I'm writing minus X, which represents the small arc. And now I need to divide by 2. At this point, you're going to multiply by 2. So that gives you 100 minus 360 minus 2x. Go ahead and move your 360, which is going to get you a negative 260, minus 2x. and then divide by -2, and you're going to get 130 degrees. Now I shouldn't just write x is 130 degrees, but it's the measure of ln is 130 degrees. And you people need to start being more clear on your homework, please, and writing out all of the steps, as well as not just x equals, but the measure of ln is 130. All right, let's take a look at number 3. I have another outside angle, so I'm going to take my big arc minus my small arc and divide by 2. So my outside angle is 20 degrees. Here's JP. JP is created by this outside angle. That's how I know I'm going to use 20, equals my big arc is 70 minus my small arc, which is the measure of JP. So I'm going to call it JP right away and write that all the way through instead of calling it X and having to replace later. Okay, so now I have to divide by 2. Multiply each side by 2. You got 40 equals 70 minus the measure of arc angle, JP. Go ahead and move your 70. So you're going to get a -30 equals a negative measure of arc JP, and then it's going to be a +30 degrees is the measure of arc JP. Let's take a look at example number 4. I'm looking for angle 1. This time I have an inside angle. Do you guys see here? These are two secant lines crossing, and that's an inside angle. So let's review that formula. Inside angle equals arc 1 plus arc 2 divided by 2. So look at your two secant lines. You are given this arc, it's 52, and you are given this arc, which is 40. So the measure of angle 1 equals 40 plus 52 divided by 2. And this should be your work, people. You should write 40 plus 52 divided by 2. You shouldn't just punch it in your calculator and write an answer down. So I'm going to add those two together. I'm going to divide by 2. My measure of angle 1 is 46 degrees. We're not going to do number 5. This is like number 2, so we're going to skip this one. Let's take a look at our last example. We're looking for the angle K. And so I know I have an outside angle. So I'm going to take my big arc minus my small arc. Now I'm looking for K, and I don't have a number here for LR. I don't want to add another variable, so I need to figure out what LR is. Notice you're given all the other angles in the circle, and arc angles in the circle, except for LR. So to find the measure of LR, you're going to subtract all of those from 360. So you're going to take 100 out of there, you're going to take 72, and you're going to take 140. It's 360 all the way around that circle. So the measure of LR equals 48 degrees. So now I can go ahead and do my big arc minus my small arc divided by 2. So the measure of angle K equals, my big arc is 72, my small arc I just found to be 48, and then I'm going to divide by 2. So I'm going to get 24 divided by 2. My measure of angle K is 12 degrees. All right, so remember while you're doing your homework, people, to write down all your work, communicate your answers completely. You guys have a great night, and I'll see you tomorrow in class.